Greetings and welcome to another installment of Quants Log. I want to say that we have an important announcement to make, but we decided it best to save it for the end of this video just so it won't serve as a distraction here. This is 38 in our basic application series, and this time around we're going to continue on with part 10 of our exciting 11-part summarizing data series. This is the penultimate installment, if you will. Very first order of business, let's take a peek at our previous Quants Log challenge here. So considering the UFO data we looked at earlier in this series, first part, do we think we can plot these data on our map? And second part, if so, what might the global distribution of sightings look like? Well, the data provides latitude and longitude for each sighting. So we can plot these sightings as points on our rectangular projection here, just like with any old scatter plot. So let's zoom in a little bit here. I think we can boil the message down pretty simply. New Fork is a U.S.-based organization, and a very, very heavy preponderance of sightings are in the U.S. And in fact, looking past that, most all the sightings are in English-speaking countries. England, for sure, Scotland, kind of, Ireland, and a smattering of sightings in Australia's Gold Coast. Essentially, nothing out over the ocean, and that's not to say that there's not a lot of UFOs out there, but it takes a person to report it. And not a lot of people living out over the ocean, not as a matter of common practice that I know of. Anyway, okay, moving on. Now, earlier in this series, we identified two attribute types, categorical and numerical. Now, occasionally, we may encounter a third type of attribute, an ordered categorical. Now, an ordered categorical attribute possesses a behavior that's sort of like a cross between a categorical attribute and a numerical attribute. And there are typically two ways in which we might encounter an ordered categorical attribute. And the first is how a unit of observation placed. And second, how a unit of observation, like a respondent in a survey, for example, rated something or responded to a prompt. So, for example, in a competition like a race, we may have recorded how each contestant placed first, second, third, and so on. Now, these values are clearly labels, but at the same time, we could say that first is greater than second in terms of performance. And these values, by the way, can be called ordinal rank. So now, ratings are commonly found on survey or questionnaire data. So in this example here, we have a test form that is going to capture a 5-level factor or a categorical attribute with 5 categories. But like with placing in a race, we can think of the category very likely as being greater in terms of likeliness than, say, somewhat likely. So you may be wondering, why did we not detail ordered categorical attributes earlier in this series? Well, for one thing, to really understand how these work, we first need to have a good grasp of how categorical attributes behave and how numerical attributes behave. But the other thing is that for most simple data summaries, we usually treat these simply as a categorical attribute. So for example, we might use a place attribute to report something like, just for an example, over the last 10 seasons, Football Club A has finished first in their league 4 times. Or with a rating, just to illustrate here, we might report that 100% of respondents say they are very likely to recommend Quants Log to a friend, just as an example. But when we are performing more in-depth analytics, like for example, when our goal is to make predictions or forecasts, we often don't make use of ordered categorical variables. So here, look, so instead of using an ordinal rank, like with a place attribute, we will most always prefer to use a direct measure, if it's available, certainly, like in a race, time to finish line, time, a numerical attribute. And with survey ratings, it is very common practice to recode the ordered categories into numbers. So for example here, very unlikely gets recoded to a 1, somewhat unlikely gets recoded to a 2, and so on. And this type of recoding, by the way, produces a so-called Likert scale, named after the social psychologist Rensis Likert. Okay, moving on, another topic here. Let us return to to two-way contingency tables. Now, two-way contingency tables are an extremely popular and effective way to show the bivariate distribution or relationship of two or between two categorical attributes. And so to illustrate here, for example, we're going to use our UFO data. What we're going to do is we're going to recode two of our original attributes. So from date of sighting, we're going to create a new attribute called a recentness. And this new attribute is going to have two categories, pre-2005 and 2005 to 2014. From the original latitude at which the sighting occurred, we're going to create a new attribute called geohemisphere. And this new attribute is going to have two categories as well, northern and southern. So here, let's take a look. Here is our frequency distribution. And let's just spend a moment with this just to make sure we know what we're looking at here. So we have a total of 80,332 sightings in our data set. One thing that jumps out pretty starkly is that a huge preponderance of sightings have occurred in the northern hemisphere, like almost 80 times as many, 79,247 compared with 1,085. Okay, so that's a pretty good first look, but let's dig a little deeper here. Suppose we're interested in comparing hemispheres in terms of sightings over time, or said another way, suppose we're interested in knowing if the trend in UFO sightings over time is different between the northern and southern hemispheres. Well, we can, in fact, use this frequency table to help us get to an answer. So in the southern hemisphere, we can see there are fewer sightings after the beginning of 2005 than before. 505 is a little less than 580. Whereas in the northern hemisphere, the opposite is true. There are more sightings after the beginning of 2005 than before. 46,973 is more than 32,274. Now, if we were to make use of a frequency segmented bar chart in hopes of helping us get to our answer, this is what we would end up with. And this is not very helpful at all. This is pretty much impossible to see the distribution of recentness for the southern hemisphere. This stacked bar chart is like itty bitty. It's too short. We can't really see what's going on in there. Fortunately, there's a much more natural way forward for us, and that is to use a row proportion contingency table. And how do we do this? So for each row, we divide the frequency in each cell by the corresponding row total. Now, of course, needless to say, nowadays, computer software does all the dirty work, all the heavy lifting. In the old days of stats, this would be done maybe with the aid of a hand calculator, and in the old days of stats, these computations would be done by hand. Wouldn't be too bad in this case. It's not too bad, just 4 divisions. But in any case, so presto. Notice very importantly that our row totals are 1. Also note that we have gotten rid of the column totals. Now, we've lost some important information by dividing out the row frequencies, so it's usually good practice to include the original row frequencies somewhere for the audience, just to convey that information. Now, okay, this row proportion table makes understanding whether there's a difference in time trend of sighting between the southern and northern hemispheres completely direct. We can simply compare, just for example, the two conditional proportions of 2005 and after sightings here. So look, 0.465 is less than 0.593. So the answer is, at least as far as the data set goes, descriptively, we see a downward trend in recent sightings in the southern hemisphere compared with the northern hemisphere. Now, the best graphical equivalent to our nice row proportion contingency table would be a percentage stacked bar chart. The red segments indicate the conditional percentage of recent sightings. So you can see here, the red segment here, conditioned on sightings in the southern hemisphere, is, well, shorter than that of the northern hemisphere. It's the same story we just told, and it is really that simple. Okay, so as I mentioned at the outset here, we have some very important and unfortunate news. Our Quants Log sponsored Alexander Solzhenitsyn epic 10-stage Beach Rager, scheduled for the week of April 12, has been canceled. And I know that this is just a huge disappointment. Some of you were planning on attending and already made travel arrangements. And well, it was supposed to be something of a surprise, but I was planning on getting on stage 3 Saturday night and busting out with some sweet pop moves that I learned back in the 80s. You know, all that aside, our Quants Log marketing team has been especially hard hit by this. And you can see there's a nice picture of them right there. And, you know, I'm not exactly sure what they're doing in the picture, but you can bet your bottom dollar it is something totally awesome. They were so excited about this sponsorship opportunity because everyone knows there's nothing that drunk party revelers enjoy more than watching statistics videos. Okay, so enough with the bad news. Let's move on to happier thoughts here. How about a Quants Log challenge? Nothing like a Quants Log challenge to bring our spirits back up. So now, here we go. Instead of using percentage stack bar charts, we could also use side-by-side pie charts. And here's an example. I think that this works okay. We can easily see the relative percent of recent sightings in the southern hemisphere is less than that in the northern hemisphere. Plus, in this example, we have the conditional percentages drawn right into the plot. So that's kind of nice. For all you artists out there, I think most people would agree that pie charts are kind of nice to look at visually. For one thing, I think circles have like some aesthetic appeal. Plus, the name pie chart makes one think of pie, and most people enjoy pie. But side-by-side pie charts are still not typically preferred for comparisons like this because in many situations it can be very difficult to compare the relative area of the slices across adjacent pies, like side-by-side. So question for the challenge here is, can we think of a way to graphically combine the artistic appeal of side-by-side pie charts with the ease of interpretation that percentage segmented bar charts offer? More on this and so much more upcoming in our exhilarating series finale, part 11. You are definitely not going to want to miss that. That's it. That's going to do it this time around. Thank you very much for tuning in, and don't forget to stay tuned for more Quants Log.